And in particular, we need the squeeze theorem because it's going to allow us to do some trig examples. Because I've already tried to sprinkle everything else in, right? I have already done some polynomials. We did complex fractions. We did ease. And we can't leave trig out because we will need to know how to do those as well. So we're not going to get all the way to the trig stuff today. You'll also notice this is 1.8, which means that I skipped 1.7. The reason I did that is because when I looked at 1.7, it had a lot of trig examples in it. And so rather than rework that entire assignment, I just switched the order of these two so we could do it in this order. And I think that will work better. I used to have squeeze theorem sort of in with the 1.6 notes. It was too much in there. So I think I will like this better. So the squeeze theorem states that if you have three functions, this is not going to help you very much. So mine is color-coded here, which makes it much easier to tell what it's talking about here. So if you have highlighters or colored pens or something and want to color code yours, it might be helpful. But the squeeze theorem says if we've got three functions, so in this case we got h, g, and f, and it is known that h is always less than or equal to g, and g is always less than or equal to f. So we've got a function that's at the bottom, we got a function at the top, and then we got a function that's in the middle. So if we know that the limit as x approaches a of the top function, which is f in this case, equals the limit as x approaches a of h, which is the bottom function in this case, if they are both equal to the same thing, right? So if our top function is equal to something and our bottom function is also equal to that same thing, then that means whatever function is in the middle of those two also has to have those same limits. Because if we've got the same limits here, it's kind of getting squeezed in between those two functions, and it has to have that same limit there. Okay, I think the picture is the most helpful here. The only way you can have the same limit for the green graph and the blue graph is for them to be at that same point, and for the red graph to still be, less than or equal to those, it's got to have that same limit there. Okay, so we're going to first look at a couple questions they might ask you that are going to be squeeze theorem questions. They don't put this on the exam much, but it could be there. And then we're going to look at how that translates to our trig stuff. And I wrote that trig stuff down, and I hope I hadn't lost that paper. Because I might have lost it. Oh, I hope I can remember it. Or that time runs out before we get there, so I can go look at it. All right, I know I remember this stuff. So we are given a function, f, such that negative x minus 2 squared plus 3. So this negative x minus 2 squared plus 3, that is an equation right there. Which one of these parabolas is that going to be? The blue one or the red one? It's going to be red. No, it's not red, actually. How do we know it's blue? That minus right there in front. So this is my blue function right here. Right? That's a parabola upside down. And then I've got x minus 2 squared plus 3. That's my red right there. And they're telling me that f of x, which I'm going to use green for, is between these two. I have no idea what f of x is or what it looks like, but for it to be between these two, it could do anything in the world over here, but right here, it's got to squeeze right through that little spot right there, right? That is my f of x. So I have provided a graph for this, which makes it pretty easy to see what the limit is going to be. They have to share that same limit right there. All right? So if the limit of the blue graph is equal to the limit of the red graph, then the green graph has to have that same limit as well. What is the limit as x approaches 2 of f of x going to be in this case? It's going to be 3. Okay, now that one gave us a graph. So if you have a graph, it makes it a lot easier to see from that. Oh, wait. I didn't put one in here that doesn't have a graph. Let's pretend the graph was not there. Okay? If the graph was not there, how would we decide what the limit was? What do you think, Aiden? Not always. Like it kind of does for this one, but it's not always. We could find the limit where we plug in 2. These are pretty easy direct substitution. So what we would do is I would need to see what the limit, so let's say it didn't give us a graph and we couldn't remember what the graphs looked like. We would do the limit as x approaches 2 of negative x minus 2 squared plus 3. And that's just a direct substitution problem, so it's negative 2 minus 2 squared plus 3, which is negative 0 squared plus 3, and that just gives us 3. Now, we couldn't just do that because there's a chance that, like, this doesn't have an answer, like does not exist, or no, like you can't make a conclusion from this. We would also need to do the same thing and check the limit of the red graph. So we'd have the limit as x approaches 2 of x minus 2 squared plus 3. And that would look like this, 2 minus 2 squared plus 3. We're getting 0 squared plus 3. That also gives us 3. So if I'm getting 3 for the limit of what I got in blue and 3 for the limit of what I've got in red, I have to get 3 for that same limit that's there in the middle. And I can make that conclusion. There's a chance they could give you one where you actually got to do some of those like limit property things like factor, cancel, complex fractions, all that stuff we've been working on, but they usually give you pretty easy ones to figure out on a squeeze theorem problem, because otherwise it would turn into a problem that could take 15 minutes to do. And they would be super hard to come up with. Usually going to be multiple choice if you see one. And it's not a really heavy topic on the AP exam either, so like if you didn't see one at all on the AP exam, I wouldn't be surprised. If you do see one, it'll just be one. There won't be more than one there. Here's an example of a multiple choice question you might possibly see. It says the function f is defined for all x in the interval from 2 to 7. Which of the following statements, if true, implies that the limit as x approaches 4 of f of x equals negative 5? So, if we run through our examples here, we're talking about a function f for this. So we have got, like I'm going to draw me a little graph right here. We got a function f, we're talking about x approaches 4. So let's put our 4 right here. Okay, and we've got some function. Oh, I should have drawn this better. Let's clear that out. I needed to approach negative 5. Let's try that again. All right, here's our 4. I need it to approach negative 5. So what I'm wanting here is, I'm going to use green for my f function. I'm wanting f to go through this point right here. Open circle, closed circle, doesn't matter. I'm wanting it to do something like this, right? So the answer choice A says there exists a function g. Let's use a different color for g. Let's call g here. We'll use a blue for g. And it's telling us f is less than g, meaning f is below g, right? And then they give us the limit. I think all my less than signs should have or equal to's with them. That is my mistake. They should all have or equal to's. I did not do that right whenever I retyped this. All of these right here should have. That should be or equal to. That should be or equal to. Equal to, equal to, equal to, equal to. Right here. That means f is below g, but g still has the same limit. So it's like right here. And g, wherever it's at, is above f. Is that the squeeze theorem? Squeeze theorem has to have something above and below, right? It's got to squeeze it in at that point. This only gives us one other function. This is not squeeze theorem. So this is not the answer. What would you say about B? Also can't be the answer because it only talks about one other function, right? All they did there was switch G's going to be below F. Can't be it, right? Let's look at C. C says there exist functions G and H. And here it tells us F is less than or equal to G, which is less than or equal to H. So that would mean F is below G, and then, like if we do H right here in red, H would be like your top function. Now that's sort of squeeze theorem, but that's squeeze theorem for which function? The G of X. And is that what we're trying to find? No, it's not that one. The last one, we're hoping this is it, and I haven't typed everything. The last one has G is less than F, less than or equal to F, less than or equal to H. That puts F in the middle, right? And G and H have limits at -5. This is the one that we're looking for right here. Those would be the correct conclusions. Okay, so that's as far as we're going to get today.